We are looking at the memory management features which are offered by 80286, 386 and 486. Now these memory management features are offered by the hardware to support the operating system to implement a multi-user multitasking environment. So we were talking about having multiple tasks resident in memory. So every task has its local data and global data. So there will always be protection provided so that the data of one task cannot be accessed by another task. So any data or code which is associated with task A may not be accessible to task B. So memory protection features are to be implemented. They can be completely implemented by the operating system, but advanced processors starting as far back as 80286 come built in with a memory management unit. So this reduces the load on the operating system. Question again is, why do we need memory management? We always have limitations in terms of the size of physical memory. It is not possible for all the applications to reside completely in the physical memory. So executing task should not access, again, a second very important reason is if task A is executing, task A should not access task B's data, or task B should not be allowed to access task A's data. So memory protection is going to be required, and memory protection can be implemented with the help of the memory management unit. To implement this memory management unit, as I said, to some extent it can be implemented by the OS, but if you want complete memory management protection, so that if you don't want task A to access the code of task B or the data of task B, or you don't want task A to access any of the OS data, in order to provide complete protection, that cannot be just be done by writing a mutex program or a semaphore implementation, you would need help from the hardware also. So for complete memory management, you need hardware support, and that is provided by memory management unit. The memory management unit has two primary functions. One, it implements the concept of virtual memory. Two, it implements memory protection. We will first have a look at the implementation of virtual memory, and then we will have a look at how memory management or memory protection is going to be done. Memory management is not just memory protection. It does two things. It actually implements virtual memory, and it also implements memory protection. So let's talk about the relationship between virtual memories and memory management unit. We have seen this already in module 6 when we were talking about how to work in protected mode, or how addresses are generated in protected mode. So we'll just have a look at these concepts once again with respect to 80286, 386, 486 processors. We'll go through it quickly. So in a virtual memory system, it is not necessary that the code and data, all of it should be present. Code and data which are currently going to be executed are loaded from the disk into the RAM. So anytime a task is going to be executed, the code or the data will be transferred from secondary memory to primary memory. Secondary memory is our disk. So from the disk, it is going to be transferred to the main memory of the processor. Now, if the executing program needs a segment which is currently not present in memory, then that particular segment will be moved from the disk to memory. So if I have an application, what I might do is I would be breaking up this applications into segments, or I will be breaking it up into modules. It is not necessary that all these modules need to be present in memory. It can be that I have module 1, module 2, module 3 and module 4. These are the 4 modules of my application. So all these 4 modules need not be present in memory. Just the required module can be present in memory. So while M1 is executing, M1 will be transferred from the secondary memory to the primary memory, and it will be executing. At the end of module 1, the processor will realize that it needs M2. So when it needs M2, that particular segment will be transferred from the secondary memory to the primary memory. Now let's assume that once M1 and M2 have been loaded, may not happen, once M1 and M2 have been loaded, the DRAM becomes full. So what does the processor do? If after M1 and M2, to complete the application, it is going to require M3. So what it will do is, it will swap the contents of memory 1 with the contents of memory 3. So the segments are going to be swapped. So now what is going to be resident in memory is module 3 and module 2. Now once module 3 is going to be completed, again now it requires module 4. So what will happen is, the operating system swaps module 2 with module 4. So virtual memory gives an appearance to the programmer that there is a large amount of memory present, but only the modules which need to be executed will be transferred from the disk into the main memory. So this is what is essentially the memory management unit's function, to ensure that whatever segment is going to be executed should be transferred from the disk to memory. What you have to do when you are writing a code is to ensure that your code and data are broken up into blocks so that they can be transferred easily into memory. Now when segments are going to be swapped, you will swap segments if you are having only segmentation. For instance, 80286 has only segmentations. So it might swap one 64K segment with another 64K segment if the memory becomes full. Or it will load one 64K segment at a time. So if I have a program which has 4 64K segments, it will load one particular segment at a given point of time. So whatever is going to be my program will be broken up into modules. Each module will be 64K. So it loads whichever module is needed into the main memory. And once it has finished executing this, then the next module will be loaded and so on. So if you have segmentation, you will divide it properly into 64K segments. If provided your program is longer than 64K segment. 64K. If your program just happens to be 100 bytes, it just fits into one segment. So if you have a long program, you can break it up into multiple segments. Or a program can be broken up in terms of pages. Pages would mean that it has to be an 80386 or 486 system. This allows a logical segment to be divided into 4K spaces. So at a time, one 4K page can be loaded into memory. And again, it is not compulsory that whenever we are talking about segment, the size of the segment must be 64K. The maximum size of the segment is going to be 64K. The size of a segment can be anything from 2 bytes to 64K. So you can break up your program into segments, and only that segment which is currently executing will be present in memory. So that is taken care of by the memory management unit. In case of 80386 or 486, you also have paging. Segments are further divided into 4K spaces, which can be used as the basic memory unit. So this is for 80386 or 80486. Now, whenever we are talking about virtual memory, what does virtual memory actually mean? It refers to the memory space that appears to be present for a programmer. So for a programmer, if he is going to look at an 80386 or 80486 address space, it will look like there is 64 TB of memory available. But 64 TB of memory is not physically available in 80386 or 486. 80386 or 486 is going to have only 4 GB of memory. Virtual memory is larger, as not all logical segments are going to be stored in the physical memory. This works because most programs need only a small section of data or code at a particular point of time. So once that particular part of the code has been executed, that can be removed from the primary memory, and the new code or the data can be transferred from the secondary memory to the primary memory. So the whole concept of virtual memory is because you have this fact that not all parts of this program must be present in the memory simultaneously. So as I said, a program can be broken up into multiple modules. In fact, a program can even have 100 or more modules in it. But at a given point of time, only one particular module needs to be present in the main memory. It is that module that is currently being executed, and all the data that is required for that particular module need to be available in memory. Once this module of the program has completed, the next module can then be loaded into memory along with the data. But as far as a programmer is concerned, it looks like he can write a very long program, and that is because this fact of mapping logical memory with the physical memory through the concept of memory management unit. Virtual memory cannot be implemented without the help of an MMU. So it is this MMU that is going to facilitate the implementation of virtual memory. So the two main operations of the memory management unit, one is virtual memory, the other is protected memory. We will see more details of virtual memory as we go on with the following sessions. So I will stop here in this session.